Hey guys, welcome back. So what we're looking at today is lesson 8, combining bases. So we are going to be looking at having multiple bases, so different kinds of bases, as you can see here, taken to exponents and seeing what that looks like in terms of multiplying them together. So the table contains products of expressions with different bases and the same exponent. Complete the table to see how we can rewrite them. Use the expanded column to work out how to combine the factors into a new base. So for this first one, we have 5 to the third times 5 to the 5 to the third times 2 to the third. So we have 3 5s and then 3 2s. Well, because they have the same exponent, we can take and do 2 times 5, which gives us 10, and 2 times 5, which gives us 10, and 2 times 5, which gives us 10. So really, we can write this as 10 to the third. I'm going to make this nice and big for us. Okay, so if we have 3 to the second times 7 to the second, well, then we have 3 times 3 times 7 times 7. So we can combine that as 3 times 7 and 3 times 7. So 3 times 7 is 21. So it's the same thing as having 21 times 21, which gives us 21 squared. So it works out. All right, here we have 2 to the 4th times 3 to the 4th. So 2 4 times and 3 4 times. Now we do 2 times 3, 2 times 3, 2 times 3, and 2 times 3. Each of those are 6. So we have 6 times 6 times 6 times 6, or 6 to the 4th. So the key thing here is we have to have the same exponent on them. So here we have 15 to the third. So what two numbers multiply to give us 15? Well, that would be 3 and 5. Being as it's to the third power, that means each of these will be to the third power. So we'll have 15 to the third times 5 to the third. We can see that from 3 times 3 times 3, and 5 times 5 times 5, 3 times 5, 3 times 5, 3 times 5, which is 15, 15, and 15, or our 15 to the third. All right, here we have 30 to the 4th. So what is one way that we can get 30? Well, we can do it with 6 and 5. We can also do it with 3 and 10, or we can do it with 2 and 15. So this one has multiple ways to take and write out the expanded form. I'm going to go ahead and do the 6 and 5. So we'd have 6 to the 4th times 5 to the 4th. So 6, 2, 3, 4, 5, 2, 3, 4 equals 6 times 5, 6 times 5. That's 3, that's 4. So then we'd have 30, 30, 30, and 30. Now it would work the exact same way with 3 and 10 and 2 and 15. We'd have them each to the 4th power. It'd work out the same way. All right, here we have 2 to the 4th times x to the 4th. So we'd have 2, 2, 2, 2, so 4 2s, and 4 x's. So then we'd have 2 times x, and 2 times x, and 2 times x, and 2 times x. So we have 1, 2, 3, 4. So we have 2 times x to the 4th. And that would be our solution. All right, a to the n times b to the n. Now, n is an unknown number, so we'd have a times dot, 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 as many a's as we can think of, an infinite number of them, times b dot, 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 once again, an infinite number of b's. And so we'd have a times b to an infinite number. So a times b to the nth power. So when we have those unknown exponents, it makes it a little harder to show this out because obviously it's going forever. We can plug any number there is in for n, but because the exponents are the same, then it works out that we can just multiply the bases and take it to that exponent. So here we have 7 to the 4th times 2 to the 4th times 5 to the 4th. So we'd have 7 times 7 times 7 times 7 times 2, 3, 4 times 1, 2, 3, 4. So we'd have all of those. So we'd have 7 times 2 times 5, 7 times 2 times 5, 7 times 2 times 5. It's 3, 7 times 2 times 5. So we'd have all of those. So then we'd have 70 times 70 times 70 times 70, or 70 to the 4th power. So that would be how we'd represent those. Now this next question asks, what happens if neither the exponents nor the bases are the same? Can you rewrite 2 to the 3rd times 3 to the 4th with a single exponent? Explain or show your reasoning. So if the exponents aren't the same, the factors cannot be grouped together evenly. No, it's not possible to write 2 to the 3rd times 3 to the 4th with a single exponent, because regrouping into factors that are 6 would leave an extra factor of 3. So it's not possible. If we can't take and regroup, then we can't write it in terms of a single exponent with these multiplied together. So not possible, can't regroup. So we have to have that same exponent. We have to, because otherwise we've got one factor that's just kind of left out there all by its lonesome that we can't forget about. Okay, so your keyword for this lesson is multiply, because this is all about multiplying these different bases with the same exponent together. If you guys have any questions, feel free to ask. Have a great day. Bye, guys.